Alright guys, so for the last part of 5.1, it is all about graphs. And so we've got quite a few graphs we have to look at. If you printed them, you're good here. If not, you're going to have to sketch some graphs and you got a lot of writing to do. So, for this graph, it doesn't have to look exactly like this. You just need to have a parabola. Doesn't matter where it touches the x-axis at, it's just got to be a parabola. And what we're going to get from here is we're going to learn to be able to look at a graph and figure out what the degree is, even if you don't have an equation. So what we're going to do is we're going to first look for the turning points. That means how many times does this graph turn around and change directions. And to find those, we're basically just looking for hills or valleys. So here I have one valley. I don't have any hills, so I have one turning point. And now this part right here in the middle, in the red and the highlighted part, that just tells you what we're going to do. It says to determine the degree of the function, add 1 to the number of turning points. That shouldn't be or, it should be of turning points. Okay, so here in the highlighted part, that's just kind of like a little formula. It says turning points plus 1 equals the degree. So if I skip down to here, and I take my one turning point plus 1, I get 2, which makes it a second degree. So now, think about chapter 4 that we just finished. Weren't all of those problems x squared problems? And didn't they all look similar to this? Yeah, so that makes sense. Now, this part in parentheses here, it will make sense after a few more examples, but I'm going to go ahead and tell you about it here. It says that this is the smallest possible degree of the function. Well, 2 is an even number, so it might be a second degree or a higher or bigger even degree. So while yes, that looks like it is a second degree, it might be a fourth degree, it might be a sixth degree. The next thing we're going to talk about is the end behavior. And when you're looking at a graph, end behavior is super easy. It wants to know which way does the left side point and which way does the right side point. So if I'm looking at the left-hand side of this graph, it's going to keep going that direction forever. So which way does the left side point? Up. And now the right side, it's going to go that direction forever. Which way is it pointing? Up. So the end behavior for this graph is up, up. And that's as complicated as it gets. Okay. When you get to pre-cal, they're going to actually throw some math, vocabulary, and terminology in there. But for Algebra 2, to know that the end behavior is up, up, that's enough. Anybody still copying? Yes. So when we look at the next graph, it's going to be a new graph, but it's going to have all the same words over here at the side. So you can copy those again if you want to, but you don't have to. Okay, so here's our next graph. And it doesn't have to look exactly like this, but you should have one hill and one valley. So looking at this graph, how many turning points do we have? 2. I've got one hill, one valley. That's 2 turning points. So once again, I'm going to take the turning points plus 1 to get my degree. So 2 plus 1 equals 3. This is a third degree. Now, once again, looking at the graph, it looks and appears to be a third degree. However, it might also be a higher odd degree. Mhm. Yeah, and not just that it's a higher degree, that it might be higher, but you got to specify odd or even. And when we've got the third example after this one, you'll see why it's important to know that. Okay. So what about the end behavior for this one? Which way does the left side go? Down. Which way does the right side go? Up. Alright, so I'm going to slide this up and we're going to look at two more graphs, and then I've got two more on the next sheet. So here, for these two graphs, I've given you the equations as well as the graphs. And if you printed these already, there's something that's left off the bottom here that accidentally ended up on the next page. You should also have end behavior here at the bottom. My page break wasn't where I thought it was. So now, if we take a look at the equation here, what is the degree based on that equation? 4. So that's a 4th degree. Is 4 even or odd? Even. Now, let's see if we can make that information right there go along with what we see in the graph. Let's count our turning points. I've got 1, 2, 3 turning points, plus 1 gives me 4, 4th degree. My equation and my graph, all that information matches together. So then, end behavior. Which way does the left side and the right side go? Up and up. Alright, for the one on the right, based on the equation, what degree is it? 2nd. Is 2, or 2nd degree, is that even or odd? Even. So now let's make sure that that information matches what we see in the graph. I've got 1 turning point plus 1 equals 2. So all of that matches up. What's the end behavior for this one? Down, down. Now I'm going to zoom out for just a second and put up a graph that we did just a minute ago. If we take a look at all three of these side by side, weren't all of those even degree functions? What do you notice about the end behavior for even degree functions? The left and the right are doing the same thing. Okay, keep that in mind. What's going to bother you?
The fact that end behavior's up there.
Just mark it out.
There'll be random markings on my paper. I'm really weird.
Here you go, Grace. Do you know how to use it?
Yeah.
Okay. Alright, so now, for these two graphs, let's look at the equation. What degree is that? What? No. X to the third. It's a third degree. Is 3 even or odd? Odd. Now, let's see if we can match that with the graph. If I'm looking at this graph, does it have any true hills or valleys? No, it kind of goes sideways a little bit, but it doesn't have a hill or a valley. So really and truly, this has 0 turning points. So 0 turning points plus 1 is 1. Well, now, if this is a first degree, what does the graph of a first degree look like? Like x to the first. It's a line. Is there any way this is a line? No. So there's no way this is an x to the first. It's not a first degree. But it could be a higher odd. Is 3 a higher odd than x to the first? Yeah. So that's why we had that little disclaimer earlier. So knowing that, my graph and my equation, it all makes sense. What is my end behavior? Down, up. Right, for the one on the right, what degree is that? 3. Is 3 even or odd? Odd. If I look at the graph, I've got 2 turning points, plus 1 is 3. So that all matches. What is my end behavior? Up, down. So now, I want to go back and zoom out. Okay, all 3 of those graphs there at the top are all odd degree functions. What do you notice about the end behavior of those? They go opposite directions, don't they? So now, here is a chart to summarize all of that. So now, if it is an even degree, it's either going to be up, up, or it's going to be down, down, because they go the same direction. How do you know which one it is from the equation? Well, you look at the leading coefficient. Okay? If the leading coefficient is positive, it's going to be up, up. If the leading coefficient is negative, it's going to be down, down. For the odd degree, I know the left side and the right side are going to go opposite directions. So here's what you need to know about the leading coefficient for that. Okay, the leading coefficient tells about the right side. So if my leading coefficient is positive, that means the right side is going to go up where the positive numbers are. Since they're opposite and the right side is up, the left has to be down. If my leading coefficient is negative, the right side is going to point down where the negative numbers are. Because they're opposites, the left has to go the other way, which is up. Alright, these are the last 2 examples. Okay? We have to be able to figure out what the end behavior is when we're not looking at a graph. And no, you can't graph it on a graphing calculator to look at it. Okay, we want to be able to just look at the equation. So here's the steps. Here's how we're going to do it. First thing, for part A, I want to look at that equation and figure out what the degree is. So what degree is it? 3. Is third degree, is that even or odd? That's an odd number. Now, as soon as I know it's an odd, in my mind, I am automatically thinking opposite directions. Now, what is your leading coefficient for this problem? 4. And more importantly, is it positive or negative? Positive. So when we deal with end behavior, I've got to do the left side and then I've got to do the right side. They're going opposite directions. It's positive, so I know the right side is up. What does the left side have to be? Down. You have to make sure you do them in the right order, which is why most of the time I draw those little blanks on my paper so I make sure I do them correctly. Right? And
So it's positive by like the sign of the
Because this 4 is my leading coefficient, and it's positive, that's how I decided. Alright, so let's look at part B. What degree is part B? 4. Is 4 even or odd? Even. When I know it's an even degree, in my mind I'm already thinking, oh, this thing goes the same direction on the left and the right. So now, your leading coefficient, is it positive or negative? Negative. So left and right, they're both going to go the same way. So which way do they both go? Down. So it's down, down. Alright, so there is your assignment.